In this video, we're going to look at some examples of solving inequalities that use addition and subtraction. So like usual, and like I'm trying to get us into the habit of, I want you to be taking notes with me because that's going to how you'll learn the most. So for our first example, we're going to have a pretty simple one. We're going to have x plus 4 is less than or equal to 10. So we're looking for values of x. Where when you add 4, you're going to have a total sum that's less than or equal to 10. So we're going to solve this using the same kind of mindset that we used when we were solving equations, even though now we have this inequality sign, less than or equal to in this case. So I'm going to look at my left side of the equation, the side with the variable, and see that it has x plus 4. So to solve for x, to isolate x, get x all by itself, I'm going to need to ask, okay, how do I undo adding 4? And how do I undo adding 4? I subtract 4. So on my left, I'm going to write x plus 4 is less than or equal to 10. Just rewrite what we have, and then I'll do it in a different color here. Then I'm going to subtract 4 on the left and the right. Because what I do to one side of an inequality or an equation, I need to do to the other in order to keep the statement still true. Okay, so when I have x plus 4 minus 4, that goes away. That's x plus 0 is less than or equal to 6. That's what 10 minus 4 is. Thus I get x is less than or equal to 6. So we would say that is the solution to the inequality. We know that 6 plus 4 equals 10, but this says x is less than or equal to 6 is our solution. Alright, so let's draw a number line. And then we don't need to put that many tick marks on there. We'll just put 4. Okay? And somewhere in the middle we're going to put 6. So that's 6. That's kind of my important number here. Okay, and then to the right of 6 I have 7. To the left of 6 I have 5. 4, and it's going off. So if x is less than or equal to 6, my less than or equal to sign, that means I'm going to put a closed big point at 6. And then it's less than or equal to 6. So which direction is less than 6? Is 7 less than 6? No. 5 is less than 6. 4 is also less than 6. So we're going to go this way. I'll do this in a different color. Okay. Where you have to move left. I have to move left of 6. So this is me graphing the solution. What this is saying is any possible number to the left of 6, or including 6 on this number line, makes our original inequality true. Just to make sure we understand what that means, right? 5 plus 4 is 9. Is 9 less than or equal to 10? Yeah, 9 is less than 10. 4 plus 4 is 8. Is that less than or equal to 10? Yeah, it's less than 10. I can pick 4.5. That's going to give me 8.5, also less than or equal to 10. This includes negative numbers like negative 100 plus 4. That's negative 96. Is negative 96 less than 10? Yeah. Right, so there's infinitely many solutions. There's not just one number that's going to solve this inequality, and that's going to be the case for all inequalities. There's lots of options, but it's not like it's all options, because 7 would not make this inequality true. 7 plus 4 is 11, and 11 is greater than 10. It's not less than 10. All right, so that's it. That's our answer to our first one. Let's look at another example. So here we have 12 is less than y minus 7. Sometimes you might see the variable on the right-hand side. Sometimes you might see it on the left. It's going to be on either side. You just have to make sure you're isolating the variable, whichever side it's on. So here I have y minus 7. And just like if we were solving an equation, I'm going to ask myself, okay, I want to get y by itself, so I want to undo whatever's currently happening to the y.
How do I undo subtracting 7? I add 7. So that's what I'm going to do to both sides of the inequality.
So I'll just start like I normally do with rewriting what I have. Here I have 12 is less than y minus 7. And then I'm going to add 7 to both sides of my inequality, again, to undo the subtracting 7. On the left-hand side here, I'm going to get 12 plus 7, that's equal to 19. And that's going to be less than y plus 0, right, if we want to include that. Or we just think we have a minus 7 plus 7, that's going to cancel away to 0, it goes away. So I end up with my solution 19 is less than y. So that's a little bit of a confusing way to think about it. 19 is less than y. So what I would do is I would find the variable and read it in that direction. So let's switch this around. So this 19 is less than y is the same as y is greater than 19. The way I turn that around is I looked at my variable y and I said, okay, is the big part or the small part facing the y? The opening is facing y. So if I'm going to try to switch anything around, I have to make sure that's still true. So here I have y, and I should have the bigger part, the open part of the little crocodile from elementary school. The big part of the crocodile needs to be facing my y. And then on the 19, right, that's the small part, that has to be facing 19. So 19 is less than y is the same thing as y is greater than 19. Which should kind of make sense if you think about it. It's flipping it around. Alright, so then from there, that's my solution. I could have circled in either of these. These are both my solutions. But it might just be a little bit easier to think about it this way when we go to graph. So to graph it, I'm going to need a number line. And I'll have 19 at the middle. 20, 21, those are numbers that are greater than 19, that are moving to the right. And then we have 18 and 17 here. Okay, so y is greater than 19. One thing we know is that if I just have a greater than or less than sign, if I don't have an equal to, then I'm going to actually draw an open circle around that number. So this is an open circle at 19. My answer doesn't include 19, but it includes every number close to it, right? Like this is going to be greater than or equal 19, so like 19.000001, right? It's going to include that. So that's why we still think about 19 as the important number. And then again, it's y is greater than 19. So we need to choose all the numbers that are greater than 19. So we're going to go right, because 20 is greater than 19, 21 is greater than 19. Any of the numbers to the right of 19 are greater than 19. I'll shade that in. Right, and that's going to be the graph of my solution. I'm just taking a second to check again what this means. My original equation says 12 should be less than y minus 7. So let's pick some solution that I've graphed. 20, right? That's supposed to be a solution to the inequality. So that means when I take 20 minus 7, I get 13. Is it true that 12 is less than 13? Yes, 12 is less than 13. So we're good, right? And that's going to be the case for any of our solutions. So here are two problems for you to try, which I want you to actually do it on your paper. Start with the one on the left. So we have c minus 10 is greater than negative 18. Guys, so you want to ask yourself, how do we undo subtracting 10? Follow the process and then graph the solution. So first, I'm just going to have you try yourself to get our solution, and then we'll get to the graphing after that. If you have any questions, ask Ms. Deliotis. Give it a try. So the correct solution is c is greater than negative 8. And you should have gotten that by undoing subtracting 10, which means we add 10. We add 10 to the left, we add 10 to the right. We're going to get negative 8 over here, and just c on the left like we want. We want to isolate c, get it all by itself. Okay, so now you're going to try to graph it. So we're going to put negative 8 on my number line. Thinking when we're going right, we're getting closer to 0. So this is going to be negative 7. It's going to be negative 9. It's going to be negative 10. So go ahead and graph c is greater than negative 8. And you should have gotten a graph that looks something like this. Since it's greater than, it's an open circle at negative 8. and it's greater than, so we're going to the right. We're getting closer to 0. Good. All right, now go ahead and try the next one. We have 10 plus x is less than or equal to negative 3. So first, just try to solve that. You should have gotten x is less than or equal to negative 13. I have a positive 10 here that I'm adding to my x. So how do I undo adding a positive 10? I subtract 10, right? Subtracting a positive 10. So I have 10 plus x minus 10. And when I have that 10 minus 10, I get 0. That's going away, and I'm just left with x, which of course is the goal. That's why I'm undoing. And on the right, I have negative 3 minus 10, which is negative 13. So my solution is x is less than or equal to negative 13. All right, now trying to graph the solution. So I'll put negative 13 right here. Okay, this is going to be negative 12, negative 11, negative 14, because this is getting closer to 0, so they're actually getting larger as we're moving right, and smaller as we're moving left, farther from 0, more negative. So go ahead and graph it from there. And this should be what your solution looks like. So since we have that equal to, right, that's going to include negative 13, so we have a closed circle, closed point. And then it's less than negative 13, so we're moving in the left direction, in the negative direction. So it's going to point left.